Oh no! What do we do?
Oh my gosh, we add 4 and then do the cube root or whatever.
Cuban.
Yeah.
Basically what we're doing here today, guys, is we're going to be solving equations that have all the different weird roots. Cube roots, fractional roots, nth roots, all that kind of stuff. You're still working backwards. There's not a lot of real craziness involved in this stuff today, but there will be a couple of tricks that you guys can pay very close attention to. You still got to get x by itself, so you move everything else around before you worry about your exponent stuff. So you add 4. And how do you undo the cube root? You cube. And 4 cubed is? Very good. And there you go. Does it work? How do you know if it works?
You substitute the equation.
Yeah. You check your work, you substitute it, and make sure it works. Cube root of 64 is 4. 4 minus 4 is? Like I said, stuff we're working on today really should not be all that scary.
Is that the hardest it gets?
No. Here's where things get weird. And it's not so much that it's really weird, it's so much in the fact that you guys haven't really solved any equations before that had fractional exponents, but you treat them exactly the same way. You still have to, we still have to get x by itself, so before we worry about its exponent, what do you have to move first? Yeah, good. So I gotta divide everything by 2. So you have x to the 3 halves is 125. Now, how do you undo a 3 halves power? Well, how do you undo a fraction? You're thinking slope, but that's great. You remember slope, but you just use the reciprocal. The opposite reciprocal is when you go in slopes for perpendicular. Bless you. So here you just have to multiply. You have to raise it to the exponent of its reciprocal. So what's the reciprocal of 3 halves? It's not slope. It's not slopes. It's not perpendiculars. It's just the reciprocal. Because what happens here is when you're raising it to the new exponent, you're doing power to power. And when you have something raised from power to power, you multiply. 2/3 times 3 halves is 1. So if you raise one side to 2/3, you raise the other side. And now your calculator has a fancy button that looks like that. You type it in, you know, the little caret button, 125 to the, just throw it in parentheses, 2 divided by 3, it'll spit out an answer for you. It's 25. Remember, the way that this is read is that the denominator is the nth root, so it's the cube root of 125 squared. So you get 25. Okay. Like I said, this is about as weird as you're going to see because you're not accustomed to working with exponents that are fractions. Just remember you're using the reciprocal. The opposite reciprocal, just the reciprocal. You've probably even solved stuff like this before. The square root of 4 minus 7 plus 2 is 5. Yeah. Start by subtracting the 2. I can't get rid of the square root symbol until everything else is moved away. How do you undo square root? Square. Square root of junk squared. And you get 4. Again, double check your work. What's 4 times 4? 16 minus 7? Square root of 9? Plus 2? Yay! Like I said, math should make you happy again today. At least for a brief moment.
Yeah.
press me something like this. Because this is where most of you guys are going to make the mistake. I had the square root of 3x plus 2 minus 2 root x equals 0. I can't square everything right now, can I? Yeah. When this happens, when you have two radicals, you want to put one on each side. Because now you can undo that square root symbol. You square both sides. The left side is the easy part. Square root, junk squared is junk. So I have 3x plus 2. The other side, you got to be careful. You've got the quantity 2x, or the quantity of 2 times the square root of x squared. What that means is that. Okay. That's what that means. 2 root x quantity squared is 2 root x times 2 root x. So what's 2 times 2? Square root of x times the square root of x. Is it x or x squared?
X.
Square root of x times the square root of x is square root of x squared, which is x. That's where most people mess up. Remember that this is a power rule. This is a power rule. When you have something in parentheses, you have to distribute your term to both. It just so happens that it's 2x to the 1/2 squared. So you're using those exponent rules and doing 2 squared, and you're using your power rules. That's where that comes from. Okay. So what's x? 2. All right. Again, double check it, make sure it's right. What's 3 times 2? 6 and 2 is? What's the square root of 8? Should know that one. It's 2 root 2, because what's 2 root 2 minus 2 root 2? Okay. That's where you get 0. X minus 4 equals the square root of 2x. Again, I have to square both sides right away. Do you agree? Okay. What do you get on the left side?
8x.
Good, good, good. Last hour, they all forgot that.
Did you tell puppy that?
No, I just yelled at them. Remember, when you have junk squared, it means junk times junk. All right. Now you're going to set one side equal to 0, and we're going to factor again. So what times what is positive 16? You add together to get negative 10. So what are your zeros? 8 and 2. Now here's where it's important. When we have two separate solutions, we have to make sure to double check. Do they both work? Does only one of them work? Does neither of them work? Things like that. We've been kind of nonchalantly checking our answers, just kind of verbally going through them. But when you definitely have two of them, you really want to make sure that they work. So you substitute back into your original equation again. We'll start with the 8. 8 minus 4, does that equal the square root of 2 times 8? Does 4 equal 4? Okay. Check the other one. Does 2 minus 4 equal the square root of 2 times 2? Does negative 2 equal positive 2? No. So what do I do with that solution of 2? Just cross it out. So in this case here, we had 2 possible solutions, but we only had one of them that worked. That's what they call an extraneous solution. You buy it?
I bought it.
Good.
How much did it cost?
Too much. Okay. Not that bad. Probably nice to see math that's kind of not scary for a change. I hope. Yeah. All right. Take a minute. Try those 2. So let's check, make sure we did all right. You have to remember, you've got 5 times all that junk being raised to the weird exponent. You have to move the 5 before you do anything else. You cannot raise it to the reciprocal exponent until you get rid of the 5. So I divide up by 5 first. Reciprocal of 3/4 is 4/3. 4/3 power of 8. Remember, it's the cube root of 8 to the 4th. You get 16. Add the 8 over, you get 24. And when you check that, it does work. Okay. On 9, you have to add the 1, you get 32. In that case, you have the 2/5 root of 32. So that's the 5th root of 32 is 2. 2 squared is 4. Subtract 9, you get -5. Now, that means you just got to double check, make sure your answer does work. You have -5 for a solution. What's -5 plus 9? 4. Remember, that means it's the square root of 4, which is 2 to the 5th is 32 minus 1 is, and it's okay. It works out just fine. It's okay to have that negative solution there. It does work out okay. All right? Remember, take a brief second to make sure your solutions are working. Subtract the 6, so you get the cube root of 3x is 4. Cube it.
Oh my.
Then what? Okay. So you got a weird looking answer. Check it. When you check it, you've got the cube root. What was it, plus 6? Does that equal 10? When you go to check this, you have 3 times 64 over 3. What happens to the 3's? It would cube root of 64. 4 plus 6. It's okay to get fractions, guys. It's okay. Don't give me decimals. Fractions. And then again, on the other one, subtract the 5 to start. So you have the 5th root of 2x plus 1 is 4. How do you undo the 5th root? You 5th it. So you have 2x plus 1, was it 1024?
1024.
Subtract 1, divide by 2. And again, when you go to check that, you probably recognize right away that when you take 1023 over 2 and you multiply it by 2, you get 1023. Add 1 to it, you get 1024, and we know the 5th root of 1024 is 4. And it goes on from there. Okay? So, those of you guys who are just wandering in, it should not be horrible, horrible scary.
Horrible.
It's just kind of scary, not nice. Oh yeah, that's a good one. Yours? We'll do the other two.
Oh my god, you just realized that?
Here, do these two. Try those two. Again, as you go through these, yeah, don't kill puppies. Square root of junk squared is junk. X minus 2 quantity squared is x squared minus 4x plus 4. Again, set one side equal to 0. 0 is x squared minus 5x. So you have x minus 2, x minus 3. You have solutions for as 2 and 3, which means you got to double check it real quick to make sure they work. What's 2 minus 2?
0.
What's the square root of 0?
0.
What's 2 minus 2?
0.
Does 0 equal 0?
No.
In this case, do they both work?
Yes.
Yeah. In this case, they both work, and that does happen. I want to make sure you guys check your solutions. Don't always just cross one of them off. Okay?
Would you mark us wrong if we only have one for answer?
Yes, because you're only half right.
I'm always right, so
Yeah.
your statement is invalid, is why I was going to say.
Yes. Nicely put. And then on the other one, again, you have cube root on both sides of the equation. How do you undo a cube root? You cube. So if you cube both sides, you're going to find out it's really easy.
It's nothing special.
You get 9.
Oh, I'm sorry.
Okay. Did 9 work?
Yeah, those are really weird numbers.
Yeah, you get a weird answer, but you can leave it in radical form. You get the cube root of 13. Just leave it at that.
Oh, okay.
You don't have to go. You have to use decimal equivalencies. You can just leave it at that, especially when you're checking your solutions. Now, I am not doing this. I'm changing it up a little bit because, like I said, we're going to be gone. It's on 7-6, so it starts on page 441.
Oh, you're gonna be gone. Most recent videos.
Yo, I'm not. No, I'm not doing another section tomorrow. You guys just have just to continue working on this. What I expect you guys to be able to do tomorrow is finish working on this today. You got a good 10 to 15 minutes to get started on it in class, and then tomorrow you've got class time to finish it up. You also then have class time to look back at your 7.1 and 7.2 stuff, especially those two sections. So those are the ones you guys are having the issues with. Look at the problems on the back of the book. Try some of them. Wednesday's lesson should not take the whole period because the graphing of this stuff is very, very simple. So that'll give us a little bit of extra time to review. Originally, I was going to do the test on Thursday, but I figured the benefit of the doubt, give you guys the time to go back and double check some of that stuff. So that's why I pushed it to Friday. Okay?